Hello everyone, welcome to AI Anytime channel. In this video, we are going to fine tune Idefics 2. Idefics 2 is a multimodal language model, or you can say it's a multimodal LLM having vision capabilities. The model has been, created by Hugging Face M4 team, okay, and they have created a new model called Idefics 2, which is a lightweight multimodal LLM. The size is 8 billion parameter. Llama 3 is not the only model that has been released recently. Idefix 2, I rate this better than Llama 2. We need more multimodal LLM, guys, more multimodal open source LLM. Llama 3 is just like an ordinary LLM in my views, because we already have, n numbers of large language models. Some of them are superior, some of them are like, inferior, but there is not much of difference, to be honest. You have Mistral, you have llamas, you have alpacas, you have blah blah blah. I am a believer where I want to see innovation more in the open source multimodal front, where the models have better vision capabilities. They can understand tables better, they can understand granular data better, only not text based autoregressive model. Even Jan LeCun, is the head of AI at Meta. He himself is not a fan of autoregressive LLMs, but Meta has been releasing Llama 2, Llama 3, blah blah blah. They're all autoregressive model. Nothing against Llama 3. I have a video which is giving me good views, but Llama 3 is not the only model that has been released recently. We're gonna talk about Idefix 2 in this video, which is a fantastic model. And let's jump in without talking a lot here. Now, if you look at here on my screen, I am on. Let me first run this. You need GPU to fine tune these models, 8 billion params. So you need a GPU. I'm on V100 high RAM. I'm using Colab Pro. You need you need to put some money to fine tune this. You will not be able to do it on CPU or or lower compute or consumer GPUs, like which have 8 GB 6 GB VRAM. You need more VRAMs to do that, so you need at least 24 GB plus VRAM to deal with this. Okay, and let me first install. So I'm installing transformers from GitHub source, and then I need accelerate because we're gonna use LoRa and things, PIFT, bits and bytes, quantized. So these are the dependencies that we need. Now, 3 months back I created a video. You can see it here. It's called Fine Tune Multimodal LLM Idefix 9B. 3 months back, okay, I have created the first version of Idefix. Now we're going to talk about Idefix 2, which is the second version of Idefix that we have. And here is the source Hugging Face repo. You can see by Hugging Face M4 Idefix 2 8B. This is the model that they have created over here, and you can read, accepts arbitrary sequences of images and text inputs and produces text outputs. That's what it says. The model can answer questions about images, describe visual content. So you can also build, a visual image captioning kind of task if you are having, or if you want to understand a given image, or you want to do visual question answering and things like that. You can use this model, or you can also further fine tune it on your data, and that's what we're going to do in this video. Now, simply behave as a pure language model without visual inputs. You can also just act as a LLM. So I rate this better than Llama 2, 3, Mistral, whatever that we have, because it's a multi-purpose LLM. It's a multi-purpose, multimodal AI that understands visuals, that understands text, that understands almost, all of these dimensions of data that we are talking about. And from Idefix 1, the improvement has been on the OCR, and I'm going to show you a live demo of it, document understanding and visual reasoning. That's what the improvement has been, guys. And it's Apache 2.0, so anybody can take these models and make it an application or vertical SaaS and commercialize it, make money out of it. You can do that here. Now, this is the repository. You can see the dataset used to train Wikipedia, Databricks, Dolly 15K, OpenHermes, and things like that. You can find it out over here. That's the model that's the dataset that have been used. Now, you can see this is where I'm installing it. Okay. Now I'm gonna have import torch. So let's get torch, and after that we're gonna have from PIFT. I'm gonna import LoRa config. So let's get LoRa config. Yeah, LoRa config, and then from transformers we need auto models, auto processors. Let's get auto processor. So auto processor, and then we need bits and bytes config. Bits and bytes. Let me see what it is given. It is given auto model for causal. We'll not get this from causal. Let's get it from even transformers has an Idefix class as well. So we're gonna use it Idefix. Whew. I think they would have updated. Okay, Idefics 2 for conditional generation makes sense. So I'm gonna use this. Okay, and now let's import this now. And once you import this, let me bring. Okay, now we are done with this. I will also open my GitHub quickly because I have created a couple of gist just to copy it from there to save some time. Let me go to my gist, and here are my gist. Okay, these are the things that I'll probably need later. Come back over here, and then I'll just click this for now. Okay, we don't need that. And let's set a device. We need CUDA. So device, we are using CUDA colon, and we have one GPU. And then let's have some constant. So I'm gonna have use LoRa. I'm gonna do this false. It's a Boolean value. So use LoRa false and use QLoRA. So I'm gonna use QLoRA because I'm gonna write some code here. Let me just do this. We need processor for tokenizer and things. So processor equals auto processor from pre-trained, and not this is how we gonna define, and we're gonna pass the model name here. So let's just get this, and let's come here and paste. And now I'm gonna do image. It has splitting, so you can also split the images, but I'm gonna make this false. Do image splitting. I hope I have one here. ah yeah, do splitting false, and let's get the processor. And you can see we have the tokenizer, the config, JSON, and things like that. This is fine now. Now what I'm going to do here is, guys, let me probably see if I have that. Okay, I have this config. So let me just get the config in quickly. This is a very repetitive thing. I have a lot of fine tuning video, guys. Please watch my fine tuning playlist. I'll explain that though. So let me just bring it over here. Let me explain what we are trying to do here. We are saying if use QLoRA or use LoRa, whatever you select depending on what kind of compute power you have. I'm saying LoRa config equals LoRa config, the class that I'm using, and I'm passing a rank which is 8, LoRa alpha, LoRa dropout. If you want to understand what does this really mean, I will recommend you to watch my fine tuning crash course video, okay, which is a 120 minutes video. I have covered each and every hyperparameters and explained what all of these things mean. I will give the link in description. Now here I am having a target module that I have taken from the documentation, that this is the target module for this particular model. We're gonna only fine tune these modules, not all the, of course, we're not doing a full fine tuning here. And Dora is a new, I wanted to create a video on Dora, but I saw there was not much significant improvement in performance, so I didn't create. So it has used Dora false if you use QLoRA else true. We're gonna use with the Gaussian LoRa weights, and then if use QLoRA, and this is what we're gonna use. So we're gonna use BNB config, bits and bytes. We are saying load in 4 bits, so we're going to load the model in 4-bit, load 4-bit quantize NF4, which is a kind of a data structure based on quantile quantization. I also have covered that in my fine-tuning video. BNB 4-bit compute D-type torch float 16, and then getting the model over here. You can see the model Hugging Face M4 Idefics 2 8B, and I'm using the class the Idefics 2 for condition generation, and then blah blah blah. If you need, let me just write it over here. This works for A100 or H100. If you need flash attention to compatibility, you need these two. So probably it will not work for us. It will be a bit faster as well if you do that. Now, there are different ways you can reduce. Let me just write it over here, guys. Meanwhile, it's getting to load the model. So I'm going to write something here. How can you reduce GPU computation? Because these are really important if you have compute limitations. So reduce GPU memory consumption. So let me just write it over here. Consumption to, and the first one is using 4-bit quantization. Using 4-bit quantization is the first that you can use it. The next one is fine tuning. You can use PIFT, you know, either LoRa or QLoRa, whatever. And then you can go with, you can, when you are working with the multimodal kind of an LLM, right? When you have, you know, with the models has vision capabilities. Basically, they are vision encoders. These are the layers that we have that's called vision encoder layer. So you can also freeze those. You can freeze vision encoder if you want to reduce memory compute. So that's what called freezing vision encoder. So that will get freezed. So basically, That will help you save some GPU compute. And then you need smaller batch sizes, with high gradient accumulation. Gradient accumulation is really important to understand for parallel GPU computation, guys. I've covered that in the video as well. Please watch that. I recommend you watch those videos. Okay. Now I'm gonna say small batch size with high gradient accumulation. I just wanted to quickly write it here that what are the things that you can try it out if you want to reduce memory consumption or GPU compute, by the way. Now the next is you can also disable image segmentation. So let me just write it over here. So disabling image segmentation. And then of course flash attention, and there are a lot of tools that you can use. You can use Exeltol, you can use Llama Factory, you can use Unsloth, blah blah blah, and those are just the low code no code tool that has been created for the developers, just to save some time, because you don't have to write all the lines of code to fine tune LLM. So you can also use flash attention. So I'm just going to write here flash attention. And this is how you can reduce the GPU memory consumption, guys. These are important. Now let me tell you how, while it's loading the model, let me just show you which data set we are going to use. So we're going to use doc VQA, doc visual question answering. It has a 200 examples by Nil SR. So this is the one we are going to use. You can look at over here. It has a data, it has a data info JSON, and that's what we're going to use here, guys. So this is the no not yeah, this is the one we're gonna use this probably. Let me just go to Nielsen, not the donut one. Uh, 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 it has a data set that, let me see. Otherwise, I will have to check my notes. Yeah, this is the one, not a donut one. This is the data we're going to use, doc VQA 1200 examples. Each sample includes a list of images, questions, and answers for that document. The questions are written in multiple languages, but we'll only focus on English in this video. So we'll just do that. So let me just now write it over here. You can see the model has been loaded it's loading in the memory. But meanwhile, I'm going to write the code for data set. So you can take any other data set. You can also create your own data and put it on Hugging Face and then import it from there. Or you can also do it locally. But I'll recommend you do that. Okay, I just ran it. I will recommend that you first upload even privately on Hugging Face, because it has easier conversion to Parquet and things like that. It's basically easy to maintain it, guys. Now, after that, I'm going to write train data set. So let me just quickly write this few things and load underscore data set. And I'm going to pass this data set over here. Whew. And then I'm going to have, of course, split equals train. This is fine. And I'm going to have a, whew, I'm going to have a train data set and one more data set, and that should, we can remove that, right? So let's have to remove, as I said, we have to remove some columns. So it has a remove underscore columns. By the way, it's not showing because the previous cell is running. I wanted some support on that, but we don't need a unique identifier, which is an ID. We don't need the bounding boxes because we are not doing a segmentation or object detection task. So let me just get rid of bounding boxes and also the answer. So I'm gonna get rid of answer as well. Okay, now we're gonna have eval. Yeah, I'm gonna have eval dataset, and let's call it split as test, by the way. And ID bounding boxes answer eval dataset dot remove columns. This makes sense to me, guys. I hope it's making sense. ID bounding boxes answer. Yeah, this makes sense. And I think we have loaded the model now. If I'll just add something here. Okay, let's add and let's just print the model. Once you print the model, it will show you all the pipeline entirely. Let me just get this in, and let me just get this in. It will take a bit of time, guys, to download the model. It's like a bit bigger model. Then you can also get the samples. Let's get the sample in. So for that, I'm going to write train underscore dataset and then pass let's get the 11th one. Okay, so we're going to get that. train date. Okay, there's something wrong, guys. Excuse me. And you can find out this. Okay, this is what you find out. You can look at here. It's an image which is an PIL pillow query. You can find out the query which is used to evaluate ART, blah blah blah, and then it keeps on going. Then we have the answer. Okay, a second, a dachi test or whatever. Okay, so that's what it is. Okay, now I'm gonna get the image also. So let's get the image. Let me get the image here. Train underscore data set, and then you get this particular image. So I think this is how you can parse the image. Let me have a look quickly here. What's the output for this? Yeah, this is how we can parse image. It's a dictionary. So we can get the image, I think, like this. And you can see this is an image. How fantastic this now we are going to do here, guys. You can look at this is the image for this one, which says Philip Morris USA inter-office correspondence. And this is what it is. Okay, now let me just go further in. And we're going to use data collator now, which is really interesting. So let me just show you what we mean by data collator. Now, data collator, if you look at here, it takes a list of samples. It can take a list of samples and a return 4 input tensors. So it will give you 4 input tensors to feed the model. It's basically a transformers class. If you look at here, it says data collators are objects that will form a batch by using a list of dataset element, not a class. I'll take the statement back. It's an object. Data collators are objects that will form a batch by using a list of datasets element as input. These elements are of the same type as the element of trained datasets or eval dataset that we're already using. Now we're going to use data collator. I already have created a gist out of it just to save some time, but I'm going to explain that. You can see collator pi. I'm going to go raw here. Control A, Control C, come back, put it over here. Now, if you look at data collator, what we are trying to do, it basically helps you pre-process in a way that LLM can accept that as an input. That's what it does. So it has an input IDS that index apply. Let me write it over here quickly. As far as my information that I have, I'm just going to write it over here so you can understand better. You will not say that, okay, I just pasted it. So let me just write. So it has an input IDS, which is nothing but the input index supplied to the language model. Then number 2, and then we have attention mask, which you'll probably already know. Attention mask for input IDS, each input IDS. And then next, what next? Let me see that. Processor dot apply processor. Then you have, yeah, then you have pixels value. Pixel values. Basically, these are pre-processed pixel values for to encode the image. Now, Idefics to treat the image at its native resolution, which is up to 980 pixels, and native aspect ratio. Then the pixels value, and there are more as well. The pixel attention. So if you have a pixel value, that attention mask needs to be created for pixel values as well. So I'm just gonna write it over here. What's happening? When I said what's happening, I just remembered something, guys. Excuse me for that. There's a famous meme that is happening, in the cricket world. That's called. There was a reporter, in somewhere in Bangladesh, which says final match you perform, what's happening. So it's just like fun. Pixel attention mask. This will be attention mask for pixel values. Okay, that's what it is. Now I already have this, so I'm just gonna run this now here. Okay, processor apply for the data collator. Now, once you have the data collator, we're gonna write the learning parameters or training arguments. And so let's do that. So for writing training arguments, you should get it from transformers, import training arguments. I should have created a gist for this as well. It will take a bit of time. And then get trainer in. This is what we're gonna get it here. So training arguments and trainer. Now I'm gonna write training args here. So let me just write training underscore args, and here training arguments And a bunch of things will go here as a hyperparameter. The first is number of training epochs. So number train epochs. I'll train it for one epoch, guys, only. Per device train batch size. Let's keep it one. Gradient accumulation steps. Or let's train it for two epochs, and then per training, let's also give this two, and let's gradient accumulation step 8. I have explained that in my previous video only, guys. What does this mean? Watch that video. I'll give a link in description, where I only covered these training arguments, not nothing else, only whatever goes in the training arguments. Now, we missed eval as well. Per device eval batch size. That is right. Per device eval batch size. I'll keep eval as 8. Per device eval batch size. And warm up steps. So let me just get warm up. Warm up steps. Let's keep it not 500. I'm not gonna do that for that long. Then you have weight decay 0.01. Then you have learning rate, weight decay. Let me just put a learning rate here. Learning rate. I'm gonna put it 1e minus 4. Yeah, that is fine. That's what they recommend. That's what Hugging Face transformers documentation. Weight decay. Logging steps. Let's keep it 25. You're gonna probably do it for 100 steps. You can do it for, depends on GPU compute, guys. Ooh, let me remove this for now. Logging steps. Logging steps is done. You need an output directory, and in output directory we're gonna probably keep this as content. Output directory content, and then save strategy. Save strategy. And save strategy, I'm gonna keep these steps. Save strategy and save steps. Yeah, save steps 25. Let's keep it 25. Evaluation strategy, or no, not that. Save step 25. Save steps 25, and after that I'm gonna keep save total. Save total limit. Let's keep it 1. Save total limit as 1. FP16, I'm gonna keep this. I'm not gonna keep evaluation strategy, then it will take a lot of time for evaluation. FP16 floating point 16 true. Push to hub. Can we try it out? Push to hub model IDs, but before that I have to, I think, log in. So I'm just gonna log in anyway. Push to hub model IDs, and we can give it a name, something. Okay, I can say it. Idefix 2 8B 8 be fine-tuned multimodal, and this is fine. We'll check that out, guys. Push to hub. I'm gonna have remove unused columns. This is false, is fine. And report to, you're gonna do vendor B, you can do that. Tensor board, weights and biases. I'm gonna keep this none here, guys. So let's do that. This makes sense. Let me go to Hugging Face quickly. I'm already on Hugging Face. I can just go to settings. Let me go to settings. Let me take an access tokens. Of course, I will delete that. Okay, all are read. Let me create a new token. I'm gonna write this. I'm gonna say writing. Generate a token. Control C. And here, what I'm gonna do now. Whew, after this, I'm gonna from Hugging Face underscore hub import notebook login. I'm gonna do notebook login here. You can log in through here. I'm not notebook login, and then keep on writing here things. Okay, notebook login, and let's get this done. And here I'm gonna pass my login thingy, and you can see it logged in. And we have a training arguments. Let me read it. Training argument, number of train epochs 2, per device train batch size, per device eval batch size, gradient accumulation steps 8, warm up steps 50, learning rate 1e minus 4, weight decay 0.01, logging steps 25, output directory content is fine. Let me just expand that. Okay, content, save strategy steps, that is fine. Save steps 25. And save total limit 1, FE16 true. Push to hub looks good. Let me run it once and see if I'm getting any error here. It says push to hub model IDs. Okay, it's not BID, it's only BID. Huh. So if I come back here on my thingy, which is, let's go to schema. Okay, so far so good. Can push to hub. I'm gonna start trainer here. So let me just do trainer equals trainer, and inside trainer you're gonna pass all of your data thingy. Model equals model. So let me just do model equals model, and args equals training args, and then we have data collator. Yes, that is fine. Data collator equals data collator, and train data set equals train data set. I don't want to click on eval and stuff, okay, in this one, so I'll just gonna ignore this. It will require a lot of additional memory, so I'll just skip this for now. I'm not training the best model out, guys, there, but I'll recommend you don't do that. You should train it fully. Let's start the trainer, guys, and see what happens. Okay, now trainer is good. We'll do trainer.train and see if it's started training. It will take a bit of time, guys. I'll take a pause here. I'll come back once the model has been fine-tuned. So you can see that the model has been fine-tuned, guys, for 100 steps. You can see it's for 124. So we did it for epoch 1 by 2. You can see because we have trained it for very less epochs and very less steps. I'll recommend you at least to do it 1000 plus on this data set to get better. But if you look at the training loss also, it's decent. It's pretty average, not that best model. We are not trying to train a best model. Just wanted to show you how you can do it, because when you are doing it, you'll be doing it, of course, with a better compute. Now let's try it out, some inference. So for example eval data set. For example, I'm going to do this on, for example, with 5, and then I'm going to have example, and you can see, let me go up. Answer is 6. As you can see, there's a question. It says, what is the number of persons present for the sustainability committee meeting held on April 5th, 2012? So we are just finding out on the eval datasets. You can do it on your own samples. You upload, use pillow to do it, and then tokenize it, and then try to generate the answers. But the answer is 6. Let's try it out if we are getting on eval, at least on this one. So what I'm going to do next is, now, okay, example image. We'll see the image. So it will give you the image. It's just a dictionary. You can see this is something. Okay, it's the page. Report on corporate governance. It's by ITC, and you can find out everything. Committee strength, number of members present, 6666667, whatever. Okay, now let's just keep on. Here I already have a gist. Let me go back to my gist here, just to save some time, guys. But you can also evaluate. If you want to evaluate, you can use Levinstein, ANLS. Okay, I'll probably talk about that in a quick. I think they have given that in documentation as well. You can look into it. Now I'm just gonna copy this here, model.eval. Come here, and you can look this what I'm doing here. I'm saying, okay, model.eval, excuse me, model.eval image example image query, and then I have a messages where I'm saying answer briefly. You can also ask different type of questions, and this is how you can also do it when you upload your own image. You can see what I'm doing. I'm first applying a chat template, and then this is very important, this line that you see, inputs. In input, if you're passing your own images, then you have to make these changes here, and then generate IDs, and then just let's run this. You can see 6, which is the correct answer. This is the answer that we wanted to have. Now on evaluation is fine. Now how you can evaluate this. So you can evaluate using ANLS, okay, which is average normalized. What does ANLS mean, full form? Yeah, NS metric. This is fine. Okay. Yeah, average normalized Levenshtein similarity. Basically for OCR mistakes, you can find it out. You can use this to do it. Probably I'll give the gist in description, guys. You can try it out yourself. I'm not writing it here. Okay, so this is how you can do with that. You can install Levenshtein package and then you can just get it done. Now this is what it is, guys. This is what I wanted to show you. How you can see this is here. It has been saved called checkpoint 100, and you will be feel free to use the model and let me know your findings, thoughts, and feedbacks. That's all for this video, guys. I hope now you have a basic understanding of how you can fine tune a multimodal LLM. Okay, not only text-based LLM, but also having vision capabilities. You can upload your own data on Hugging Face, excuse me, and you can fine tune Idefix to IMP v3, Lava, or any kind of different multimodal LLMs. The structure are fairly, I think simple of data that create. We have to create a JSON file, keep the images in a folder, and then create a JSON with images, question, answers. And this notebook you can follow it to do that. It's good. It's pretty decent. I have tested the analyst previously. I've read the blog also. I think it was 60 odd percent, which is fairly good. Not the best. You have to increase it to 80 or 90. 64 is not good. But if you do it for more epochs, more steps, it will be definitely good. If you have any question, thoughts, let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. If you like the content I'm creating, please hit the like icon. And if you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. Thank you so much for watching. See you in the next one.